Assalamualaikum and a very good morning to our beloved lecturer and fellow classmates. We are from group number 1 and today we will be presenting our mini project for our course subject 50203 Reinforced Concrete Design taught by Madam Fauzia binti Aziz. Our group have 4 members including me, Amalina binti Sini Ibramsah, registration number 50 DKA 21F1018, Fatin Elisa binti Rusli, registration number 15 DKA 21F1009, Maisara binti Zairul Adham, registration number 15 DKA 21F1049, and lastly Fakira Shakila binti Zulkifli, registration number 15 DKA 21F1082. Our mini project includes design and calculation from roofing to ground floor, so we need to follow the requirements given from the plan to design it. We have to calculate reinforced concrete slab, reinforced concrete column, and also reinforced concrete beam for each floor, complete with the drawing detailing.
Hello, my name is Maisara. I will present reinforced concrete design for slab. For slab, first of all, we need to determine the slab thickness. The minimum thickness for fire resistant and estimated thickness considering deflection control, H will be chosen in an interval of 25 mm. Then, calculate slab self-weight. Permanent load excluding self-weight for characteristic permanent action GK and characteristic variable action QK. The design action ND formula is 1.35 GK plus 1.5 QK. Consider 1 meter width WD equal to ND times 1 meter. The main reinforcement effective depth D, design moment MED, minimum and maximum reinforcement area are calculated then. After that, calculate the shear reinforcement AR. Design shear force VED, design shear resistance VRD, C to get the shear value. Next, calculate deflection. Percentage of required tension reinforcement ρ, reference reinforcement ratio ρO, factor for structural system K can be viewed from table to determine if it's one-way or two-way slab. Modification factor for span less than 7 meter is 1. Modification factor for steel are provided AS provided divide AS required. Therefore, allowable span effective depth ratio L divide D allowable actual span effective depth L divide D actual can be calculated if it's bigger than or smaller than. Then, for cracking, calculate H and checking the main bar and secondary bar by referring to the formula. If the number is smaller than 400, then the spacing is okay. Lastly is doing the detailing for the slab design by following the requirements given and calculation.
Hi, my name is Fakira Shakila. Next up, I will talk about the reinforced concrete design for column. First of all, we need to check the dimension and size. For column, B times by H, IZ and IY. Beam, main beam by time by H, second beam, B time by H. Moment of inertia, I column, IZZ and IYY. Beam, main beam, I secondary beam, I. The stiffness K is equal to EI divided by I, and the relative column stiffness K is equal to K column divided by 2, total of K beam. For effective length column, radius of gyration I equals to I divided by A times 1 divided by 2, slenderness ratio I equals to LO divided by I. Slenderness limit, lambda lim equals to 20 times A times B times C divided by bracket and 1 divided by 2 close brackets. Lastly, calculate the effective length of column following the simple method, factor time by clay height for both x-axis and y-axis.
Hello, my name is Amalina and I will explain the reinforced concrete design for beam. First and foremost, determine the overall depth using the formula H equals to L over 13. You can choose any number from 8 to 13. Then, width B equals to 25 times H. Next, determine the minimum cover with regard to bond C min B, minimum cover with regard to durability C min dur, and minimum required exit distance for fire resistance A. Min cover with regard to fire C min. These are all gotten from the table of requirements following the specifications of each beam. Allowance in design for deviation, CDEV, used is standard of 10. Finally, we can get the nominal cover C norm using the formula C min plus C diff. Next, calculate the loading and analysis for slab self-weight permanent load excluding self-weight, characteristic permanent action JK, and also characteristic variable action QK. Characteristic variable action, design action ND is 1.35 GK plus 1.5 QK. Consider 1 meter width WD equals to ND times by 1 meter. Then calculate main reinforcement effective depth D, design moment MED, and minimum and maximum reinforcement area using the formula given. Make sure the 0.5 D is used.
Hello, my name is Fatin Elisa and I will continue on from here. Next, calculate area of compression steel, area of tension steel, and minimum and maximum reinforcement area. Then, calculate the shear reinforcement. First, determine the design shear force VED and the concrete strut capacity, which the formula includes 22 degree cot theta and 45 degree tan theta, which the equations should be repeated twice to determine the angle. After that, for deflection, percentage of required tension reinforcement P, reference reinforcement ratio, is calculated using the formula given. The factor for structural system, K, should be determined by if it's one-way or two-way slab. Modification factor for span less than 7 meter equals to 1. Modification factor for steel are provided, A as provided by A as required. Therefore, allowable span effective depth ratio L over D, allowable actual span effective depth L over D. Actual can be calculated if it's bigger than or if it's smaller than. Then, for cracking, the limiting crack width W maximum is determined because usually cracking can happen anywhere caused by strains not considered in design. Determine if the cracking is okay. Finally, do the detailings for the beam design by following the requirements given and calculations. That's all from us. Thank you.